Hello, good morning, and welcome back to math class in session. Today we just do what we did yesterday, except we do it in three space, r cross r cross r. The standard basis vectors for r cross r cross r are I, j, and k. For example, I is 1, 0, 0, j is 0, 1, 0, so it goes one unit along the y-axis, and k is 0, 0, 1, so that would be 1 unit from the origin up along the z-axis. So we've got three basis vectors, the standard basis, and any position vector OP can be represented as either the three components or OP, which is, well, that would be the linear combination of the basis, where the origin 0, 0, 0 is the origin, and any point is some other point in r cross r cross r. Example, use the prism and Pythagoras to find the distance OP. We want to go across through this box, through the air in a box, in a rectangular prism. Given that this edge is vector A, this edge is vector B, and this edge is vector C. And A, B, and C represent magnitudes here. I didn't put little vector symbols on them. So they're just the magnitudes, or the distances. First of all, we find OD. That would be the distance across the floor, or the bottom of this prism. And we can see that there's a right-angled triangle here because this is a right angle in the corner. And so this distance OD, and of course this distance is also A. So OD would be a square root of A squared plus B squared. And now we want to get OP. Use Pythagoras to get OP. There it is, there's OP. Now if you look here, you'll see a right angled triangle. Okay, and so again, Pythagoras, OP equals OD squared plus C squared. But OD, we know to be, we've already figured it out, it's the square root of A squared plus B squared. And so when you square that, you just get A squared plus B squared. And so therefore, OP itself is the square root of A squared plus B squared plus C squared. Example, given the 2 points in 3 space, A, -5, 6, -8, and B, 4, -2, -12. Find the position vector AB, as well as its magnitude. Solution, well, we subtract backwards just like in 2 space. 4 subtract -5, comma, -2 subtract 6, comma, and -12 subtract -8. Simplify those numbers, and we found the vector between these 2 points in 3 space. Next, their magnitude, the associated position vector is P, 9, -8, -4. So that would be taking this vector between A and B and transferring it so that its tail is at the origin, and from there we could see that the vector is 9, -8, -4. So it could be located in any position, but it could certainly be located with its tail at A going to B, or its tail at the origin going to this point. The magnitude is, well, we figured out it's the square root of A squared plus B squared plus C squared. And so we just plug those in and use brackets and do the math and work it out. And so the magnitude is the square root of 161. Just a short lesson for today, transferring from 2 space to 3 space.